But first, I'd really like to go over some stuff with you guys about the class. I just want to clarify, I really want you guys to know why I'm doing the class this way. Really, the flipped classroom is all about using your peers and me to assist you in class so that, you don't go home saying, what is this homework? I don't understand. And then maybe emailing me and crossing your fingers that I didn't go to bed before 10 o'clock and we'll be able to help you. So it's to prevent you from going home and not having anyone to help you, but except, your parents. It's your peers and me are the number one people that can help you. I'm the number one person, and then your peers who are learning it along with you should be able to help you too. So it might seem kind of silly now, but when we get into harder topics, you'll want as much time with me as possible. Just think about the course as being maximum teacher-to-student interaction, maximum peer-to-peer interaction, really overall good for your learning. I also want to put this out there that if from now on, if you don't watch the lecture, you'll not do the lab until you have watched it and show me the notes. So know that if you come into class and you don't have the notes, I'll just make you watch the lecture and you'll fall behind, and that kind of stinks. Your lab partner, if they do the assignment, if they do watch the lecture, then they'll work with someone who did and you'll catch up on your own. So if it just so happens that both you and your lab partner don't watch the video, you'll both watch it and then you'll both be behind. Okay? The class isn't structured for you to fail because of this, but you really don't want to fall behind because you're going to be responsible for the same amount of material as everybody else in the exam. And regarding lectures and labs, the lectures themselves, obviously not this particular part of the lecture, but the lectures give you foundational knowledge that you need to proceed on in chemistry in the labs. So watching the lectures gives you some definitions, gives you some information from me, just like you would if I were standing in front of you lecturing and you were yawning. You'd have the same information to proceed in the lab and do the chemistry, and the labs themselves are more for reinforcing and building on the material from the lecture. Just a quick note about assigned work, anything that I give you guys to do. The POGL worksheets that we do are always done with your lab partner, and they will never be homework. So if you don't finish those in class, you'll just put them aside and come back to them next class. Okay, they're always meant to be done with somebody else so that you can have someone to help you work on it. Okay, lab-related questions and write-ups are stapled together on lined paper. These may become homework. If you're working on the lab and you finish the lab during class but don't have time to get to the post-lab questions and the write-ups, that becomes homework that's due next class. So sometimes this can be homework. Okay, anything, and a note to anything that I hand out to you for labs goes in the handout section of your binder. Okay, so the POGL worksheets and anything related to the labs is going to be a handout. Okay, basically anything I give to you that's not a quiz is a handout. And regarding lab work itself, this will be the only place besides an exam or a quiz that you'll be responsible for sig figs. Okay, please round any answers to 3 sig figs for any and all assignments. Okay, and a note regarding lab work, each one of you is responsible for handing in a lab report. Okay, you are working as a team, but you each have to turn in your own work, your own handwritten work. Little more here. I know this isn't about elements, compounds, and mixtures yet, but I still want to tell you guys about the course structure. So once we get settled in, I gotta be honest with you guys, I'm still working on really getting a flow to this class and really getting it the way I want it to work and the way it's going to work ideally for all of you. So I know it hasn't been perfect and everybody makes mistakes. I've made mistakes in the class already. It hasn't cost anybody learning, I don't think. That's the ultimate goal for me, is making sure you all learn. But once we get settled in, I really want the class to run in this order. Okay, we're going to have a lecture and a pre-lab, which will be one thing. Okay, so you'll get a lecture that also has the pre-lab in it. Okay, you won't get any handouts anymore with pre-lab questions on them. They'll be within the lecture. Okay, that will be done at home or possibly at the end of class if you finish everything up and have time to start the lecture or even watch the whole lecture during class. Then the lab. Okay, that'll be in class with extra time if you need it. I have office hours And before and after school, you guys can always come in and finish up labs. If you are just taking a little bit longer than everybody else in the lab and you still need to get it done, okay, you've got to do the lab to get credit for it, okay? Following the lab, you'll have a lab report, okay? That's going to include the pre-lab that you did, the lab itself, the data collection, and then any post-lab questions, results, and conclusions, okay? You've got a worksheet, a handout thing that I gave you guys for doing lab reports, and we'll kind of build and work into that as we go out throughout the year, okay? So that'll be built into these lectures to help you guys get to the point where you're writing really excellent lab reports, okay? That's also, lab reports are also done in class, so you can work on them with your lab partner, each coming up with really good things written down, and finishing it as homework if you don't get it done during class. Then a quiz over 2 or 3 labs, a couple lectures, like you just had. Okay, you guys all did pretty well. A general note for the quiz for Chem Kids. I want you guys to review scientific notation and, more importantly, taking things out of scientific notation and back into standard numbers. So taking 2 times 10 to the 6th and making it into 2 million. Okay, things like that. Just review that. And for IS2 kids, you guys did pretty well also. Okay, and then we'll repeat steps 1 through 4, lecture, pre-lab, lab, lab report, quiz, and take an exam. Okay, so with that, checking your notes. When you come into class, you're going to have lecture notes and pre-lab stuff. Okay, make sure you've done those 2 things on different pieces of paper. Notes are going to be with one thing, and then the pre-lab stuff is going to end up being in with your lab report, so you want to make sure that you've done that. You know, you haven't written it into the same thing as your lecture notes. You don't have to rewrite it or anything like that. Okay? So, but anyway, regarding checking your notes, the earlier you get to class, the earlier I can check your notes, and the sooner you can get started on the lab. Okay? So ideally for me, you know, you guys come in as the first bell rings. The first set of lab people that get there, I'll check your notes. I'll just go through, check them, check your pre-lab, make sure you're ready to go in the lab, and you just get going, get started, okay? I'm not going to stand up in front of you guys and make announcements and this and that unless there's something really important. But I'm not going to stand up in front of you guys and lecture. You guys have the full 80 minutes, plus or minus 5 minutes on either side, depending on how much time you know, how long it takes you to get here. You guys have the full 80 minutes to get through the stuff I assign to you as a team. So the earlier you can get here and the earlier I can check your notes, the sooner you're going to be able to go through and do the lab, etc. Okay, so be jealous of people who get there first and can get started in the lab sooner. They will get done faster and probably have less homework.
And so I'm back with another meltdown in audio. Hopefully you can hear me okay over the squeaky chair and all that. I broke this thing and got a new one. This is the new one, and it doesn't work. So hopefully you can get through this just fine. I fixed the mono and stereo audio thing, so hopefully that works out better for us too. So with that, this is the Introduction to Bonding and Polyatomic Ions, lecture number 7. So to start, we really need to look at the periodic table. Dmitry Mendeleev, he was looking at all of these elements. He found all kinds of stuff and discovered similar properties, okay, which we call recurring trends. In other words, periods, okay, things that happen at different periods, periodic table, recurring trends. Write that down. Okay. This is what his periodic table looked like. It's a little bit different than the one you're familiar with, but I thought I would show it. So why do we put elements into families? He looked at similar properties such as behavior, densities, charges, conductivity, all kinds of stuff puts elements into their families. And I'll show you in the periodic table. The thing we're most concerned about for polyatomic ions and for chemistry are their charges.
So we have put hydrochloric acid in these 3 tubes and then diluted it with water. We are going to put tin, copper, and magnesium strips in each of them. There are really big pieces of tin in here.
Ooh. Grab them. That looks good. Shiny. So, you want to swirl the other 2 around, see what's happening? Anything? Okay. Nothing.
Nothing. We got a little bit of bubbles.
Bubbles?
Little bubbles. You get little bubbles.
Stick that in there and swirl it around. Anything? Okay. All right, so what's happening with the other one?
It's fizzing up. Magnesium is fizzing. It fell to the bottom and it's fizzing.
Okay, so do you think, is it producing gas of some kind?
Yes.
Okay, so how would we go about testing something like
It
that?
smells really bad.
All right, so an odor. How might we go about testing that? If there's a gas produced.
Letting a match in front of it.
Oh, let's give that a try.
I warn you, I'm horrible with matches.
That's okay. Drop it right in there.
That was funny.
So what was that reacting with?
The hydrogen gas.
Incredible. Nice job, Liz.
Okay, I have 20 centimeters of magnesium that has been coiled up and 1 gram of calcium. And I'm going to put them each into, it's about 20 milliliters of hydrochloric acid. And so here I go. The magnesium is obviously reacting faster and more vigorously and creating more gas.
Actually, you can see it. You can kind of see it on the screen. Really good. And you can hear it.
Yeah.
This one is probably not so much. Okay, so Liz, would you like to explain why the magnesium seems to be reacting faster and more readily?
Because on the periodic table, magnesium is higher than calcium, and the higher and farther over that the element is, the higher ionization it has.
So you guys took home from your exam, you should have taken home periodic table, okay? Make sure you put your name on it, okay? Get that periodic table out, pause if you have to. Okay, good, you're back. So, I just want you guys to label this as I do. The metals are, first we make a little stair step, okay, which you might already be able to kind of see. Make a little stair step, don't blot out the masses like I just did. You make a little stair step that goes down, nice and neat like this, okay? Metals are on the left. Metals. Metals, okay? Non-metals are on the right, over here. Okay, I'm just going to write NM for non-metals. Okay, make sure you guys write non-metals. Okay? Hydrogen, this little bad boy over here, is also a non-metal. So for our purposes, I want you to think of hydrogen as being over on this side with the non-metals. So I'm going to also label it as an NM or non-metal. Okay? These right here, we call the transition metals. I'm just going to write TR metals, TRM, okay? These are transition metals, okay? Everything to the left of this staircase, so everything, including these guys over here, are metals, okay? But these are known as transition metals, which I've heard some people call them schizophrenic metals because when it comes to charges, they don't have the same charge like a lot of other periodic elements. So metals are very shiny. They have what we call a luster. They're lustrous. We actually have a lot of metals in the back room. I can't let you go and look at them, but we've got a lot of the same ones that I'll show you pictures of as I'm talking so you guys can see them. And also, there are only 2 metals that are not silver, and that's gold and copper. Okay, so that's something you need to know. Any metal you're looking at, you're going to see that it's silver. Also, they are malleable and ductile, which malleable means that you can move that you can bend and break them, as you'll see in the demonstration, and ductile means that you can pull them into the form of a wire. Also, of course, they're conductive, which means they conduct electricity. Nonmetals are kind of boring. They're dull and brittle. They don't conduct electricity, and most of them have lower densities than metal. So just thinking about the differences, I will show you some pictures here too.
So we are going to compare the difference between element aluminum and aluminum with a compound. So
What's happening?
it's smashing and becoming a powder.
Just mushy.
Just kind of mushy. And
It's really bright orange.
yeah, it's really kind of stuck there. There we go.
All right. So what happens when you, what's the aluminum foil? What happens
The
to that?
aluminum foil is pure aluminum.
Okay, so.
Mm.
Oh, okay. And the wire.
Mm-hmm.
Go ahead. Give it a couple more. Alright, so it's pretty malleable, huh?
Hmm.
Hmm. Okay, here's the periodic table again. And what I want you guys to do is label the same charges that I'm about to label, which would be, we'll start over to the left, all the way over to the left where this family group number 1 is +1. Right, and then moving over, the next group is +2. These are the charges that their ions hold, and I'll tell you more about that later on. We're not going to label any of the transition metals because, like I said, they're schizophrenic. They don't actually have the same charge. Sometimes they can be +2, +3, +1. Okay, so that's what we will get back to that as we need to. And moving over toward the right side, we have +3. I'm going to write right over this stuff. So +3. We actually skip these. And then we move over here. Now, do you guys think, what do you think? +3, +4, +5? No, actually, it's -3. Okay, write that down. Moving over, we actually start going down. This is -2, -1. And these lovely guys over here, we know them as noble gases. They actually have a charge of 0. They are very happy to be as they are. They don't have a positive or a negative charge. They pretty much don't interact with anybody. Okay, so these are the noble gases over here. Just a quick note about charges. So you just put the charges on your periodic table. And so you need to know that pure elements don't actually have a charge, but atoms can gain or lose a charge by gaining or losing electrons. So this is called an ion, and this is what we're going to be working with from now on. We're going to be working with ionic bonds, ionic charges, ionic compounds, lots of cool stuff with gaining and losing electrons. And I don't want you guys to worry about the electron piece. We'll get to that eventually. For now, you guys just need to know +1, -1, and all that. Okay?